Okay, I think I have this working. Greetings to the first gen ruse. Um, I kind of I didn't forget about you. I just am putting this together on it's Friday, uh, August 14th, and I think you're coming on campus Monday. Um, and welcome aboard. And I don't know if you're on campus or I think this is being done virtually. So we've got some things that you can do if you're like the one person in your dorm room, or I don't know really how it's working for you all. So maybe I should stop speculating. Introduce myself. My name is Bob Riggs, Dr. Bob Riggs. I teach physics at UMKC, and I teach a myriad of courses for those of you who are uh, budding biologists, chemists. If you're going that pre-med route, you will all paths go through physics 1 and 2, which is some students dread it, and then they realize, oh, this wasn't so bad. And basically, what I wanted to talk, we're going to take, let's have a moment of science here. Okay, we're gonna pause and have a um, do a moment of science instead of silence. I also have another one where science is like magic, but it's true. And I also have um, more science, less friction, um, or less fiction. So um, anyway, as in science fiction, but so we're and then I got like one thing for a little activity for you to do later on, and I'll show you a video that I made of this that I did of me making this little boomerang thing. Um, I would have had more for us to do, but oh, and I also have an activity you can just do at home, or all of these you can do at home. And I had a couple, but they required too much social interaction because that's the problem with doing science it's not it's a team sport, and so it makes it difficult because you have to be together, and one person's taking the measurement while the other person's doing the experiment and things like that, so it becomes difficult. So what is science? What is that? Well, let's take a uh, science basically is the way we look at nature, and then we do experiments, all right, and to validate results or to discover something new. That's one of the things. Uh, Sometimes scientists get in their own way. Uh, One of the most famous experiments is to actually they got um, Michelson actually kind of screwed up in reverse because back in the early 1900s, because he was trying to find an ether. You can hear my voice. You can hear my voice because of the sound waves that um, goes because sound has to travel through air. Sound needs a medium to travel through, or underwater. If you've noticed, you can even scream underwater and you can hear somebody, or you can really hear somebody with if you're underwater and they clang on something metal, because that travels because those sound waves they need a medium like water, metal, air, something to travel through. Whereas electromagnetic waves, which are light waves, um, which are this, and that electromagnetic um, thing is actually what turns the lights on and everything else. And we learn all about that in physics too. Um, it, and but the early science it hadn't been that hadn't really been proven yet. A guy by the name of Hertz um, was Heinrich Hertz was working on it, and based on Maxwell's equations. I'm kind of going really into the weeds here on the history of things, but when things need a medium, like you can hear that, right? You can hear that, and so that's the way sound works. However, in space, no one can hear you scream. Why? Because it's a vacuum. There's nothing for the sound to travel through, and that's what the early scientists could not understand. They were like, why is it? Um, there's got to be an ether in the universe that the Earth is traveling through. Like a soupy thing, because we're getting heat from the sun. We're getting the electromagnetic waves from the sun and light, and we're getting heat, and we're getting So those are waves, and they have to propagate, and we can measure the velocity of the ether that the Earth is in, because we're going to take measurements and find the speed of light. And what they kept finding out was based on Maxwell's predictions. They kept coming up with their speed of light was, and these were like huge experiments. I mean, they were setting up giant mirrors 30 on mountaintops, 35 kilometers from each other, that would rotate, and then they would take the measurement based on the diffraction pattern, and based on science that was done in the 1800s that was building on it. So it was fascinating stuff. But they kept coming up with, they're going, we can't find the ether, and the ether's got to be there because the speed of light isn't changing. It's not changing. It as the Earth turns, there should be a change, or due to the ether affecting Earth. Just like if you're rowing a boat, and you want to cross a river, and the river has a current that's going this way, you're going to have to head at an angle if you want to go straight across, right? Well, that's what they're trying to measure. They're trying to measure what's that angle, and that the Earth has to meet, and they couldn't find it. They were like, the speed of light is the same everywhere. Right. That was the answer. But they kept making the experiment more and more elaborate, and more and more, and they refused, and these were supposedly the smartest guys in the room. One of the biggest problems with science is that it's always been done by white males historically. Okay, and so there weren't enough people in the room. But maybe if they'd asked someone else besides, the old white males, they might have come up with a different way to look at the problem, and solved it sooner. But now it's getting better, especially in the biological. The medical and the biological science are light years ahead of the physical sciences in promoting diversity. But anyway, so that's what we're going to, and I want to show you a quick film on the scientific question.